This video is on relations. Some things we need to know. Coordinate system, quadrant 1, 2, 3, 4, x-axis, y-axis. Where they cross is the origin. The first number in this ordered pair is the x value. The second number in this ordered pair is the y value. This is 2, 3. A mapping illustrates how each element in the x values or the domain is paired with each element in the y values or the range. X values, y values, domain, range, independent, dependent, input, output. We'll look at that some more, but a set of ordered pairs is called a relation. Here is a set of ordered pairs. So this is a relation. These ordered pairs were given as a mapping here. Let's look at some other ways ordered pairs can be given as relations. These are relations. Here's a set of ordered pairs, 1, 2, -2, 4, 0, -3. That can be given as a table. All your x values are your y values. As a graph, you plot each of the 3 points. And as a mapping, which looks a lot like your table, except you draw an arrow from the x value to the y value, 1, 3. The x values of relations are members of the domain, and the y values of relation are members of the range. In the relation above, the domain values are -2, 1, 0. -2, 1, 0, -2, 1, 0, given in numerical order. And the range are your y values, -3, 2, and 4, -3, 2, and 4, -3, 2, and 4. It's your y values given in numerical order. So domain are your x values, range is your y values given in numerical order. Here I'm given an equation, y equals 3x. This is the table. All of the x values on the table are your domain. They're also your input. They're also your independent. All of your y values are your range. It's also your output. It's also your dependent. So if I input 0, 1, and 2 in here for x, my output is 0, 3, 6, and 9. If I input 3, right here, 3 times 3 is 9 right here. So your x value 9, your y value 0. And I can list these relations as ordered pairs as a table, just like you see it, as a mapping, or as a graph. Main thing you need to know here is domain, input, and independent are your x values. Range, output, and dependent are your y values. Let me tell you one more thing. In order for something to be a function, every x value can be paired with one and only one y value. So my x value of 1 is only paired with one y value, 3. My x value of 2 is only paired with one y value, 6, and so on. So this is, in fact, a function. One more look at all of these. If I have a quadrant 1 graph, my x-axis and my y-axis crosses right here at the origin. This is quadrant 1. All of your x values are independent, domain, input. All of your y values are dependent, range, and output. Everything that happens on the y-axis depends on what happens on the x-axis. So back to this one we looked at earlier. Every x value is paired with exactly one y value, so that one is a function. Let's look at this relation. 1, 2, 3, 4 sets of ordered pairs are given as ordered pairs. They're also given in a table. They're also given in a graph. They're also given in a mapping. The domain and the range. The domain are all of your x values in numerical order, and the range is all of your y values in numerical order. Is this a function? The answer is yes. Every x value has only one y value. The x value of 2, one y value. X value of -2 has 1, 5 has 1, and -1 has 1. Every x value has only one y value. Now, My y value of -2 has two different x values, but that doesn't matter. Does every x value have only one y value? And in this case, it does. Just looking at another example real quick. I have 4 ordered pairs. Here's my table. Here's my graph. Here's my mapping. My domain are all my x values. My range are all my y values. It is a function. Every x value has only one y value. So here's another example. Here are my ordered pairs. Here's my table. Here's my graph. Here's my mapping. Take a minute and jot down the domain, which is also your input and your independent variable, and the range, which is also your output and your dependent. And also, is it a function? So your domain values, and I do not have these in numerical order, but you should have written -2, -1, 2, and 5. And your range is -2, 3, and 5 in numerical order. And yes, it is a function. Every x value is paired with only one y value. Another example, ordered pairs, table, graph, mapping. Same numbers are used in all 4. What's your domain? What's your range? Is it a function? Your domain is -2, 4, 5 in numerical order. Your range is -6, 2, 3 in numerical order. And yes, it is a function. Every x has only one y. We'll see some examples of not functions here eventually. Here's another example. You don't even have to write it. Just think about this ordered pairs, table, graph, mapping. What's your domain? What's your range? Is it a function? Think about that real quick. Your domain are all your x values, which should have been written -4, 0, 3, and 4. Your range is all your y values, which should have been written -3, 1, and 2, if I do it in numerical order. What about this one? Here's an ordered pair. Here's a mapping. What is my domain? What is my range? Is it a function? My domain is 4. My range is -3 and 2. Is it a function? No. Your x value of 4 has two different y values. Your x value of 4 has a y value of -3 and a y value of 2. Also shown here in the mapping, this x value of 4 points to two different y values. So no, that one is not a function. Think about these ordered pairs. What would be your domain? 0, 3, and 5. What would be your range? -2, 2, and 6. Is it a function? No. Your x value of 5 has two different y values. It has a y value of 2, and your x value of 5 has a y value of 6, so it's not a function. Here's the same thing as a table. Your 5 has two different y values. Here it is as a graph. We won't worry about that right now since it's not on graph paper. Here it is as a mapping. Your x value of 5 has two different y values, so not a function. And here are your domain and range. Your domain 0, 3, and 5. Your range -2, 2, and 6. All right, last example. For something to be a function, every x value can have only one y value. Here are ordered pairs. My x value of 2 has a y value of 3, and my x value of 2 has a y value of 4. So no, not a function. The x value of 2 has two y values, 3 and 4. Here's a mapping. Is this a function? Yes, every x value has only one y value, or every domain has only one range, or every input has only one output. I want to briefly talk about input output again. So this is a function because every x value has one y value. But think about it. If I input a 2 right here, 3 times 2 is 6. I get one output of 6. If I input a 2 and I get multiple outputs like 6, 8, and 9, well, that's not a function. That's just kind of crazy talk until you understand different ways that could actually be done. But if this were graphed, it's a positive sloped linear equation, straight line. It is a function because no matter what you input here for the x, you're going to get one output. Look at 29, 30, and 31 and think about each one and answer yes or no. Is it a function? Yes. Is it not a function? No. Every x value can have only one y value. The answer to number 29 is no, not a function. My x value of 0 has y values of 0 and 1 and everywhere in between. My x value of 1 has y values of 1, 2, and everywhere in between. So this is not a function. Is number 30 a function, yes or no? Number 30 is not a function because your x value of -2 has two y values. It has a y value of -2 and it has a y value of +2. Is 31 a function? Yes, every x value has only one y value. Even right here at 2.5, you don't have a y value here because it left it open. You do have a y value here. Another way you can do this is a vertical line test. You can take your pencil or something straight, go across it. If it crosses more than once, it's not a function. So right here, not a function, good, 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 not a function, good, 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 not a function. Here, I'm good. All these spots here, vertical line test passes, but right here it does not, because right here my vertical line crosses twice. It crosses right here at +2 and right here at -2, so it does not pass the vertical line test. This one passes the vertical line test. Even right here, it only crosses one time at a y value of 0. So it does pass the vertical line test. Try these three. Yes or no? Are they functions? A, the answer is yes, it is a function. At no point did my vertical line cross twice. When my x value was 1, I only had one y value right here. When my x value was 2, I only had one y value right there, and so on. Is B a function? B is not a function because of these stair steps. At my x value of 1, I got multiple y values here. My x value of 2, multiple y values. My x value of 3, multiple. My x value of 4, multiple. And from here over, we're good. But here, 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 and here make it not a function. What about C? Is that a function? Yes, every x value has one y value. It passes the vertical line test. X value of 1, y value of 2. X value of 2, y value of 2 3/4, and so on. Look at these and determine, are they functions? 1, 2, 3. Are they functions? Number 1 passes the vertical line test. Every x value has one y value. Yes, it's a function. What about number 2? Number 2 does not pass the vertical line test. Everywhere on the right side over here that I put my vertical line, I get two y values. Max value of 1, two y values. Max value of 3, two y values. So not a function. What about the third one? Is it a function? Yes, even right here at an x value of 0, I only have one y value right here. This one is open. So yes, that is a function. It passes the vertical line test. And every x value has only one y value. Every input has only one output. Every domain has only one range. Let's do some more. Number 4, is it a function? Yes, every x value has only one y value. Now I got a y value with two x values, but that's okay. This is a function. What about number 5? Yes or no? Is it a function? No. Which x value messes it up? The 2. The x value of 2 has two different y values. If I graph that, those would be on top of each other and not pass the vertical line test. Number 6, is it a function? No. Which x value messes it up? The 24. The 24 has an x X value of 24 has a Y value of 1 and a Y value of 5, so not a function. Number 7, is it a function? Yes, no matter what you input for X, you're going to get a different output. 1 here, 4 here, 2, 5, 3, 6, 4, 7, 0, 3. So yes, that is a function. What about number 8? No. Number 8 is not a function. Which X value messes it up? 1. The X value of 1 has a Y value of -1 and a Y value of +2, and it would not pass the vertical line test right here. Number 9, is that a function? Yes. Every X value has only one Y value. Passes the vertical line test. At no point does my vertical line cross what is drawn more than one time. Number 17, yes or no, is it a function? No. What X value messes it up? The 3. X value of 3 has two different, well, actually it has the same Y value of 4, so let me back up and say that is a function, because that's the same. If I put a dot at, well, that depends. Let me actually look up the answer before I answer that. One moment. I don't have the book that goes along with it to get the answer, but if you plot 3, 4, and then you put a dot on top of it, 3, 4, you won't know it. It's just one dot. So I'm going to say that one is a function. What about 18? Is that a function? Yes. Number 19, is that a function? Yes. Number 20, is that a function? No. What X value messes it up? The 3. 3, 6, 3, 2. 21, is that a function? Yes. 22, is that a function? Yes. And if I had to give the domain and range, let's just pick 21. My domain values are -3, -2, -1, 0, 1, 2, 3. My Y values are -2, -1, +1, and +4. So I need to be able to give the domain and range for any of these 6 as well. So quick review. This is a set of ordered pairs. Those ordered pairs can be given as a table, as a graph, as a mapping. Your X values are your domain, your input, and your independent. Your Y values are your range, your output, and your dependent. Domain is a list of all your X values. In this case, it's 0, 3, 5. Range is a list of all your Y values. In this case, it's -2, 2, 6. For something to be a function, every X value can have only one Y value. This is not a function because your X value of 5 has 2 different Y values. This is not a function because your X value of 2 has 2 Y values, 3 and 4. This is a function in this mapping because every X value has one and only one Y value. That is your, let me show you one more thing. So I'll show you one more time. Your X values are your independent, your domain, and your input. Your Y values are your dependent, your range, and your output. For something to be a function, every X can have only one Y. As a table, this is a function. And given as an equation, we can still tell it's a function because every input gives us one output. And that is your video on relations. Thank you.